So we are at the last session of the day. Thank you for staying here all day. The idea of this session is to see how we can use serverless technologies to build a backend using GraphQL. That is quite a different protocol than the traditional APIs that we normally build with REST. So let's see what are the advantages. So what we see is that when you need to build an application that has a front end, like a mobile app or a web application, it's not easy to build this kind of data-driven application because the data requirements, they change with any device. So for example, if you have the same application on a small screen, like a smartphone or in a tablet or in a web application, you tend to show different amounts of information. And this normally means that you need to change the APIs depending on the device and can be complex to manage. Users are now really, they expect instant access to their information. In the past, before mobile apps were so much diffused, people were expecting a slightly slow behavior, for example, from a web application. Now everything must be fast like a mobile app. So every time you are a little bit slower, the users, they feel it and they don't like it. And users also, they want to work with the mobile app, for example, when there is no connectivity. You go on an elevator, maybe you commute, there's some period of time when there's no connectivity. You want to be able to maybe not use all the functionality, but still have something that you can do in that period of time. And still building a complete distributed backend for this kind of application is something quite complex and requires some effort on your side. REST is the traditional approach for backend APIs, but probably is not the best approach for user interfaces, so for mobile apps and web application. Main reason is probably chattiness. If you trace any REST API call, there's lots of data on the wire, even if the actual payload is small. There's too much information. And also REST doesn't have support for features like real-time and offline. So if you want to push information in real time, now you can use WebSockets, you can use HTTP2, but there is no support in REST APIs for real-time notification. It's something that you need to build yourself. And also, there is no offline support, apart from maybe implementing some kind of caching. If there is no network connectivity, you need to build the logic to manage the lack of connectivity for your application. And when we talk of speed, this is probably what we see now. So we see that below 100 milliseconds, people feel interfaces like being very fast. OK. 100 to 300 milliseconds, it starts to feel not OK. From 300 milliseconds above, your customer will start to say, this is not working, and then you can lose the customer, and maybe it will never come back. So speed is also very, very important for the front-end application for user interfaces. And GraphQL is a query language and a runtime for making queries to data from a user interface much easier to build. So normally with REST, we create resource endpoints, and then we have operation on those endpoints. So let's imagine you want to build a blog. You have a /post resource where you can post information, and then you can start using that. And then you realize that for your index, you don't need to post all the information because you need to move lots of information over the network. You consume the bandwidth of your users, but then you just need to display a subset of the information. So you create another endpoint to get only the information on that post, or maybe just the title. And then you need to search your post by author, or maybe depending on the name that are there, and then you need to manage comments. And the idea is that with REST endpoints, it's very difficult to grow a REST endpoint in a correct way. This is probably a very bad example of how to build things with REST, but even if you do everything by the rule, it's not an easy task. With GraphQL, this problem is not there, because with GraphQL, you have a single endpoint where you run your queries. And GraphQL works in this way. First, you can declare the schema of your application. Let's say that you want to build a to-do application, like the classical to-do list. I have these things to do. With GraphQL, you can create a type, to-do, and then declare, OK, to-do item as type as an ID that is mandatory because there is the exclamation mark, as a name, a description, a priority, and a due date. And then on top of these types, you can define queries that say how you want to get this information. So the client needs to get the to-dos, the to-do items, and this is a list of to-do type, list because there are the square bracket. So now we have a schema that says what kind of data I want to process and how I want to get the information on the data. Now the client can run the query. The client can say, I want to run a query. I want to run the get to-dos query. And every time the client is running a query, can be a mobile apps, can be a web application, it can specify, it must specify what information that is in the data I want to get back. So if I want just the title, if I want the full information, you can choose that when you run the query. You don't need to have different queries for that. And the result will be a JSON payload with exactly the minimum amount of information that I ask for. So the ID, the name, and the priority in this case, and there is no mention of due date, for example, or the description. So this is making the use of bandwidth much more efficient, so it's faster, especially for mobile apps, and you don't consume bandwidth for your users if you don't need the specific information. So is REST dead then? No, of course, REST has lots of possible use cases. My idea is use GraphQL when you have a user interface where data must be presented. Data is an important part of your user interface. Data as a structure so that you can model data in the way that I showed before. And most of the interaction are query-driven, so you are really running query on the data to extract information. A side effect of using GraphQL will be that some of the business logic will move from the backend to the front end. So also the development effort will be more on the front end. So if you are planning on defining a team, consider that there will be more effort on the client and less in the backend with GraphQL. But of course, you must continue to use REST when you want to leverage all those amazing features of HTTP protocol, like caching, like media support, like content types. And also, if your data really maps very well to a resource, then REST is the correct protocol. For example, we use REST for Amazon S3. It's a resource where you create a bucket, then you can put data and get data, so it maps very well to REST. It doesn't make sense to change that interface. Let's, for example, build together the schema for the GraphQL schema for an application where we can map events like this, like the builder's day, and then we can add comments to those events. So I create a type event. The event has a unique ID, has a name. This is the builder's day, a location. We're in Dublin, a date, a description. And then an event can have a list of comments, again with the square brackets. And each comment has an ID, is linked to an event ID, has some content, the text of my comment, and a creation date. You see how I'm really giving a structure to the information that I want. On top of the schema, we must define the way we want to change the data, so how to insert and update and delete the data. And this is called mutation in GraphQL. And for example, this is a little bit of a simplification, but in this case for events, I want to be able to create an event, to delete an event, and to add a comment to an event. So create event, I need all the information of the event. To delete an event, I need the ID. And to add a comment, I need which is the event I want to comment on, the content of my comment, and the creation date. After the mutation, we can define the query, so how to get information from my data. So I want to be able to get an event by ID, and I want to be able to list events and filter the events, and maybe all those APIs that normally can have an unlimited length of results. Normally, they require pagination because HTTP and most protocols, they have a timeout. And normally, pagination is probably one of the most boring tasks for a developer. I don't know if you ever built APIs with a pagination. I always find it extremely boring. So this is here. It's implemented in the protocol, and you will see that you don't need to do pagination. We can build that pagination for you with some tools that we created. So we have the schema. We have how to update the schema, the data, how to query the data. And more recently, GraphQL added the capacity to create subscriptions. And subscriptions are real-time notification that you receive in a push way on your device, on your mobile phone or on your web application. And the way we are implementing subscription in AWS is to link subscription to a mutation. So the idea is that you create a subscription. For example, the name is subscribe to event comments. And you specify the event ID. So I want to subscribe to comments to this specific event, the Builders' Day in Dublin. And this is linked to a mutation. So every time there is comment on event, so the mutation is triggered, this will fire a subscription if the event ID is the one that I'm subscribed to. And then you receive a real-time notification. Our SDK is automatically using WebSockets to do that, so that you receive a real-time notification in a web or mobile application. So lots of the features that normally you need to build for your APIs, real-time support, pagination, search, offline support, are part of the standard. So it's much, much easier to build APIs for a front end. To make it easier, last year we launched this platform, AWS AppSync. It's a managed service that allows you to use GraphQL with real-time and offline capabilities with flexible database options, and also a very fine-grained control on the security of who can read or write to the data. So AppSync works in this way. So this is the core service. You start by uploading a GraphQL schema, similarly to what we did before. Then you can connect data sources that can be DynamoDB table, a Lambda function that will do whatever you want with the query or the mutation. The Amazon Elasticsearch service, if you need to search data with the capability that Elasticsearch gives you. Any HTTP endpoint, those can also be reached. And more recently, we added support for relational databases. The support is currently only for Aurora Serverless, because we use a new RDS data API that you can use to query Aurora Serverless without a database connection using the AWS control plane. So it's quite an interesting evolution of how we operate with relational databases. So now that we have the data sources, and here we have the schema, we need resolvers. And resolvers map the operations, so the query and the mutation and the database structure and the data structure to the different data sources. So the resolvers are written with Velocity templates from the Apache Velocity open source project. And it's the same syntax that we use in the API gateway. Good news is that most of the templates are automatically written by us. So you normally only need to update something if you need to add additional, for example, security. But most of the time, you don't need to touch them. More recently, we also added support for functions. So if you have similar activities that your resolvers need to do for multiple data points, you can create functions, and then you can create a pipeline with multiple functions. So you can create very sophisticated resolvers that, starting from some data, can do elaboration and then present a different data through the GraphQL schema. And when everything is set up, you can connect your client using GraphQL and run your query, your mutation, and get your subscriptions. We have an SDK that you can use that will make this very, 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 very easy. For authentication, we support API keys. And this is something that you should use only for development, because API keys can be intercepted very easily. We support Cognito User Pool if you want a full user management platform, from verifying email to verifying the phone number and all the life cycle of your users. If you need something more sophisticated, we support AWS IAM. This is a low-level authentication using the access keys and secret keys. But this is something that it's a little bit more complex to use, so keep it on the side in case you need something more advanced. And we also support natively OpenID Connect. OpenID Connect is a standard for federation of users. For example, Salesforce is using OpenID Connect. So if you want to federate your users with Salesforce application, you can use OpenID Connect, and you get all the users management from that. We can also create the resources for you. So if you know GraphQL very well, you set up the data, and we can automatically create the DynamoDB tables for you for that data. Or opposite, if you already have data on DynamoDB, or if you're more an expert of DynamoDB than GraphQL, we can automatically auto-generate the schema and the resolvers starting from a DynamoDB table. So you don't need to know GraphQL. We will implement everything for you. Using Lambda function is probably the most flexible use case here, because the operation, for example, to create something or to read something is given to a Lambda function that can do whatever you want. So it can be used to interact with other databases. It can be used to interact with legacy applications. Let's imagine you have a very old trouble ticketing application that has some kind of interface that a Lambda function can use. Then you can use this Lambda function to provide a GraphQL interface to a very old legacy trouble ticketing application. Another common pattern is also to use DynamoDB streams to replicate all the content of the DynamoDB table and keep it in sync on Elasticsearch. This is something that we can also manage for you. And the idea here is that if you have a transactional operation like adding information by ID, getting information by ID, the resolver will map the schema, the query, and the mutations to DynamoDB. If you have maybe full text search on your data, or you need to have spatial operations on latitude and longitude, then you can use Elasticsearch that has a replica of your data. And from the client application, everything is transparent. It's just running a query or a mutation, but this is probably a query, and it's automatically redirected to a different data source. It's managed by the resolver, and can be a good way to augment the capability of your application without having to make your DynamoDB table too much complex. Just a few words on GraphQL subscriptions. So GraphQL subscription work with any mutation. So any mutation can generate a real-time notification. So if you have a chat, for example, every time you can subscribe to a chat room, and every time there is some activity in that chat room, you receive a notification. And the way it works, you have the mutation, for example, at the post, and then you create the subscription, and you use this annotation, AWS subscribe, to create a link between the subscription and the mutation. And then the client can use this syntax, can say, I want a subscription with this name, and this is the subscription, is added post. And then for a subscription, like for queries, you can choose what is the amount of information from the mutation that you want to receive. This is important because with real-time subscription, they are pushed to the client. You need to keep the amount of data at the minimum, because otherwise you're consuming bandwidth for your users. So you keep it to the minimum. __ type name is a reserved name from GraphQL that gives you the name of the type that is used in this. This is returned by this subscription. So in this case, the subscription is returning a post. So __ type name will always have the value post. But it can be used to create a more dynamic application that can react to different data types, inferring the data types from the answer. Lots of customers are doing interesting things here. This is a customer that I think is interesting. This is Music Match. They were at reInvent last year, and they were also at the AWS Summit in Milan. I don't know if you use Music Match. It's a mobile app that you can use to get the lyrics. So you can listen to music and see the lyrics in real time, or you can just see the lyrics of a song. And they have a native application, because normally when you build customer-facing application, you want to go as much as native as possible to give the better interface to your users. But some of their users, they are power users that also want to contribute to the lyrics. So maybe they want to fix an error in the lyrics of a song, or they want to add new lyrics for a new song, or they want to improve the synchronization of the lyrics with the music. So for those users, they wanted to create a new component, and they decided that for those users, they need to go native. So they built that with React Native. That is not native, but is still providing a very good interface for your users, because it's JavaScript that is translated into native, but it's almost native. So they did a single development for both iOS and Android using React Native. And then they had the problem of caching, because users, they want to do maybe some fix or some correction, but maybe they're commuting, they lose internet connectivity. So they needed to build all the caching logic inside their application. By using AppSync, they just use our SDK, and all the offline caching capabilities is managed by us. Also, the conflict resolution in case you get conflicting messages when you merge different messages coming from the backend. So for them, it was very easy. They did a single development on React Native for all their native applications, and then they added our SDK to manage offline capability, and their users are super happy with the result. In the meantime, since last year, we also are growing what we call Aws Amplify. This is a whole tool chain. It started as a open source library. There is also a tool chain with the CLI and UI components that you can use. This is targeting mostly hybrid development, so JavaScript based, but it's also adding features for native development on iOS and Android. And the idea is to provide tools that you can use to use, for example, from the CLI very easily AppSync without not even going to the console. The CLI is super powerful. You can take a React application and integrate a React application, for example, with an AWS backend with just a few lines of code without having to configure or know almost anything about AWS. And we also launched this year at re:Invent the Amplifi Console. So if you have a web application, you can link your Git repository. It can be on GitHub, it can be on code commit on AWS. And this is mapped to an environment, and every time you commit, your application is automatically published, and all the integrations with AWS services are managed in the console. So it's quite a powerful tool. It's like having something similar to what you get by connecting lots of different services, like code build, code pipeline. But in this way, especially if you are focused on web application, you have everything under a single console. A few words before we move into the demo. Normally, when you create a GraphQL schema, you have lots of boilerplate code for query and mutation. So let's say that I want to create a note application where I write notes. I have a note ID, the title of my note, and the content of my note. But then I need to define all the queries. I want to get the note, I want to list the notes, I want to create a note, the mutation, I want to update the note. And we notice that all these are like the getter and setter when we were used to program in Java a few years ago. Everything is always the same. So we wanted to simplify. So we introduced the concept of GraphQL transformers with Amplify, where you can just add this annotation saying that the note object here, the note type, is a model, and we will automatically generate all the query and the mutations for you, and you don't need to write anything. It's also more sophisticated than that. You can add the out annotation to say that the access to the note must be authenticated, and in this case, allow owner means that only the owner of a note can read and write the note, and we will configure the security for you. If you add @searchable, means that we will automatically replicate the DynamoDB table to Elasticsearch, as I described before, and then we will create the queries so that you can do full search on Elasticsearch, but it's completely transparent for the client because we will automatically redirect some queries to DynamoDB and something to Elasticsearch. And also, if you add versioned, we will automatically version your records on DynamoDB, so there will be a version property. And this is a best practice of NoSQL databases, because if you have an architecture, maybe you read a record, and this is version 4, and then you want to update the record with some information. You want to be sure that it's still version 4, and you update to version 5. If another one already updated the record to version 5, the version number will prevent the update, and maybe you reload the data, update the data again, and then update the next version. So having everything versioned on a database is a good way to prevent conflicts when you have multiple concurrent users working on the same records. And this is a best practice that we will implement automatically for you. You just need to add versioned. We also have connection that is used to link different data types. So for example, if you have a blog and the blog has multiple posts, and each post can have multiple comments, you can link the blog with the post with this annotation, and this will help us create the right queries and the right mutations for you. All those transformers are open source and part of the Amplify library, and we also have a tutorial if you're interested on understanding how they work, or if you want to extend and add your own custom transformers for GraphQL. So let's see how this works practically. So from the AWS console, let's go on the AppSync console now. And here I have a few applications. And this application here, Event App, is actually the same application that we built in the presentation, where you have events, and you can add comments to events. And then you have a subscription that gives you real-time notification if there is a new comment. So this application, we have also the source code on GitHub. So let's go in the directory here. What we can do, we can start this application. So I'm now starting the application locally. And then I start also another browser. Browser's guest. So this is now this is a React web application, React.js. Localhost 3000. It's running locally, but it's a static application. It's loaded by the browsers. This is Safari and this is Chrome. And then when I change data here, it's connecting to AppSync, and then from AppSync it's going to DynamoDB and other services. So here we can create events. So for example, I go here. Let me go, and I create a new event. So the event is Builders Day. It's today. It's in Dublin. And this is a nice event, I hope. And I save this. So now I have this event saved. But there is no subscription for events. The subscription was implemented only for comments. So the other client doesn't know anything yet. Here I have an explicit resync button, but you can optionally put your resync logic in the application. And now both browsers are in sync. I can now select the event, the same event here and here, and I can add comments. So for example, the last session was so boring. And you see that this is where the real-time subscription was, and the other browser received the notification. So our SDK is building a WebSocket communication, and then basically in the code logic you can subscribe to these events, and then you can, in React is even easier. You can link these updates with data structures that are automatically updated when you receive the data from the event. And I say, I couldn't stand the final demo. You know, it works also in the other direction. So this is an example of how real-time communication works, and the source is on GitHub if you're interested. And let's go back to events. So let's see offline support. There are more advanced capability for offline support, but just to show you, so I'm using the cable now. Let me just turn Wi-Fi off, and I should still be pinging. So if we go here and we reload, the network is still working, okay. Let me take the window again. So now I'm using the network here, and if we go here, we see this is the ping, even if it's not really readable. So now I disconnect here. So we have the cable disconnected, and you see that the ping is not working anymore. There is no network, but my application, it needs to continue to work. So for example, let's say that I say, okay, I want to delete this event. I really don't want to remember even that there was this builder event. I really didn't like it. I delete it, and you see no error. This is cached locally. Now, if I reconnect the cable, so let's move the ping back. It usually takes a moment. Okay, now we get the ping is back, so we get the network. Now I just resync this one here, and you see that it has resync. So this other client, when the network was back, automatically synchronized. It's managed by our SDK. You don't need to do anything. So it synchronized the data. And then this other now is in sync, and the event has been deleted in both clients. So this is a very simple example. Of course, there's more sophisticated things that you can do. We have a specific library for caching if you want. But creating this seamless experience where you don't have the network, but you can still operate on your local data, and then you resync is very important for giving a good user experience. OK, so this was the first example. But now let's create a new application ourselves. First thing, let's go on DynamoDB and show we should not have. So this is DynamoDB. I'm in Ireland, and these are the tables. OK. Now I go here and say I want to create a new API. When you create a new API, you can go with a wizard. You can import a DynamoDB table, or you can build from scratch. Or you can use one of the sample projects, including the event app that I just showed to you. So let's create from scratch. Let's build from scratch. And start. And let's create the notes app where I can write my own notes. I create this new API. I go on the schema, and now it's empty. So I should have here, oops. Let's terminate this. Let's open an editor. So here I have just a few lines of code. So let's copy this note item. It's exactly the same as before. No, sorry. Let's create a resource here, and then define a new type here. So I define a note here. So I have a note that has an ID, a title, and some content. And automatically, the creation of the resource will suggest me to create a note table on DynamoDB with this primary key, optionally sort key. You can add additional indexes if you want, or you can add them after. And it's automatically generating the GraphQL schema for getting the note, listing the notes, creating the notes, updating the notes, all the getter and setters that you can think of, and also the subscription to be notified if someone is creating a note, updating a note with some specific ID or characteristics. So if everything is OK, I can just click here on Create. And this is now creating the DynamoDB table and the resolvers, and linking the DynamoDB table with this API. So if I go here we see that now we have a note table, and the note table is of course empty. There is nothing inside. But now I can go on queries, and we can, for example, play a little bit. So I can say I want to do a mutation. So this is exactly what you would do in the client. I want to do a mutation, and I want to create a note. I need some input, and the input is I need a title. The title is very important, and then some content for my note. Never do live demos. And now I can do this mutation, and I get the ID that is automatically generated. We manage that for you. And if I go on DynamoDB, I see that now I have the record with the unique ID and the data that I was inserting. And now let's create a little bit more data. So very, very important. Never, ever do live demos. And then finally, very, very important, never, ever, never do live demos. Now, if we go on DynamoDB, we see that we have the 3 records. Now we can run some query. So I can do a query. And for example, I can list the nodes. And I want to get all the items. And I get the ID. And then you need to specify, I want the title, and I want the content. And you get the list of the nodes with the ID, title, and content. Maybe you don't need the ID for this, because this is like the entry menu of your application. And you only want the titles. You can just remove the content and GraphQL will provide you only the minimum amount of data that you need. So you can really optimize the use of the bandwidth and also the speed. And this is also actually implementing lots of parameters. So you can, for example, you have pagination. You can limit to 2 at a time, and then you get the next token. So in this case, I'm paginating with a limit of 2. Probably you paginate with a limit of 10, 20, 50, but it works the same. It's built automatically. You need to do that. So I get the first 2 items, and then I get the next token, and then I can copy the next token. That is a unique token. I can pass it here, and then I can continue the pagination with the third item. Similarly, you can filter, and filter again is very powerful because you can filter for different things like how it starts, the content, so you can filter for records that contain some specific keywords. And those filters, by default, are running on DynamoDB, and then you can extend and add Elasticsearch if you need more capability. So it's quite powerful. So this is an example of how you can start from scratch, and you can create a full backend, and then you connect your mobile app, and you can start using the GraphQL backend. If you have data already on DynamoDB, so for example, here on DynamoDB, I have this books table where there are 4 fake books. I can create a new API from the DynamoDB table. So I can say create API, import a DynamoDB table, and then you choose the region. It's the same region, it's the books table. And the book is automatically discovering the attributes of my item. This is taken from the metadata of the DynamoDB table. So DynamoDB is schemaless, so you only get the attributes that are in the primary key, in this case the ISBN, or are in any index, like the author and the title are with an index now. But I also have other things here. If I look at the DynamoDB table, I have a price, I have a year, but this can't be automatically discovered because it's actually part of each item. And there is no configuration, it's a schemaless database. So what I can do here, I can add the field and say I also have a year, and the year is an integer, and I also have a price, and the price is a float. So this is for the demo. Never use float for money because rounding is completely wrong. So never do that. But for the purpose of the demo, let's keep it like this. And let's call it my books app. And now I created a new API. And it's configuring the resolvers. And now if I go here on data source, I can, on queries, I have also some suggestion. But for now, let's just filter. So I can run a query and say I want to list my books. And I want to get only the title, and you get the 4 titles from here. And again, you get the filtering, the pagination, the next token, everything is built for you. So you just can start to use this data that was on your DynamoDB table using a GraphQL interface. So you can either start from scratch or import the DynamoDB table, and it's seamless. If we go back to the APIs, I also have this example here. So this is legacy TT system. So this is a different API that I built. In this case, the data source is not a DynamoDB table, but it's a Lambda function. That means that I can interact from GraphQL with a Lambda function. So if we look at the schema, I define here a very simple type for a trouble ticket. So a trouble ticket should have an ID, a title, and a description. And then I define a query and a mutation. I want to be able to put a trouble ticket, and I need an ID and a title. And I want to be able to query a trouble ticket, and I want an ID and a title. Here, you see how resolver works. So when you create a resolver, you can connect the data sources, so DynamoDB, Elasticsearch, or in this case, a Lambda function with any of the mutation or the queries. So in this case, I created a Lambda function, and I connected this Lambda function with both the put trouble ticket and the get trouble ticket. If you look here, you see that you can also attach a resolver to a single attribute of your object. That can create interesting use cases because, for example, if we go back to the books, the price was on the database and it's fixed. But maybe you want to create a dynamic price depending on the customer, because any customer maybe has a different discount. So you can go to the price and say attach a Lambda function to this to the price. And when the price is returned, it's not returned from DynamoDB, but it's returned by a Lambda function that is executed in parallel. And the Lambda function maybe is reading the price from DynamoDB, and then is reading the customer configuration, and it's applying some discount that the customer has, and is returning a dynamic price. So you can really create something very dynamic if you want. If we go on the Lambda function, we see that the Lambda function is actually expecting the data that is here. So the Lambda function here will get the ID and the title, and the Lambda function linked to it get TT is the same, will get only the ID. So what I decided in my code, I said if I receive a title, then I can expect this is a put. If I don't have a title, it's probably a get. So it's just a way to have a single function, nothing more. This is the function. It's very few lines of code because this could be the Lambda function that integrates with a real trouble ticketing system, but in this case, I'm just emulating. So if there is a title, I use this title and I create a fake description. If there is no title, I generate a title that is my title for trouble ticketing ID, and then hello from Lambda as description. And now that we saw this, we can go here on the query, and we can say, OK, let's do a query. And let's get a trouble ticket with ID 123. And then I want to get also the title and the description. And you see you get the information that is generated by the Lambda function. So title for trouble ticket 123, hello from Lambda. If I want to run a mutation, I can say put trouble ticket. The ID is 321, and there is also a title. So what can be a good title for a trouble ticket? Mailbox full. And then I want to return the title and the description. And now the Lambda function is using the title from the input and is generating a description that is description of mailbox full. So as in the code. So you can really customize using Lambda function and add any custom business logic you want, from dynamic pricing to interacting with legacy databases or legacy applications. It's really, really powerful what you can do here. So in the final 15 minutes, I want to show you how you can use this similar approach from the command line, and that's the Amplify command line tools. So this is Amplify. It doesn't render very well when you zoom because it needs a little bit of space, but you can add basically you can use a hybrid or application, and some of the functionality work also with native development. And then you can add a backend API that can be REST with the API gateway, or can be GraphQL. You can add authentication using Cognito. You can add backend function with Lambda. You can add hosting online using S3. All those features, you don't need to go on the AWS console. You can do everything from the command line. So for example, let's create a new React application here. And let's call it Dublin app. So this is React Web, nothing AWS specific. I'm creating a new Dublin app. It's just some scaffolding. This is JavaScript, so it's downloading half of the web to say hello world, but this is the way it works. And when we have the standard app, it's just saying something very, very basic. So it's here. We can go into Dublin app and say yarn start. And as before, it will just launch in a browser. We lost Google Chrome. So the development environment is still starting. OK. And this is the empty static React application that I just created. And everything is in source app.js if I want to customize. So let's go here, and let's transform this static application in something that can use the cloud. So we need to install Amplify. So I add AWS Amplify and AWS Amplify React. So these are two open source libraries. The first is generic for JavaScript, and the second one is adding high-level components for React. So it's simplifying the way you can use React. And now that I have React installed, I can say Amplify init. And say, OK, this is a new project. It's called Dublin App. Yes. Let's say this is a beta version that I have. So I have some functionality that are still not available for everybody. But I can specify also an environment. This is production. You can choose an editor. And the CLI sometimes will start the editor if you need to configure something that doesn't make sense to do interactively. So I use this one. This is JavaScript, React. This is automatically discovered. This is where the source is, my distribution, how to build, how to start the app. I can use a local profile from my AWS CLI. And now this is initializing my project in the cloud. And it's using CloudFormation, similarly to what you saw in the CLI before. So if I go here and I go, for example, on CloudFormation, you see that Dublin App the creation is in progress. And it usually takes a few time. So if we look at the application in the meantime, here we have the Dublin app and the app.js. So this was the file that was rendered on screen that I can edit. So I can change this to be welcome to Dublin. And then, since this is now a very important application, I want to add authentication here, for example. So to add authentication, I just need to import a few lines from Amplify. So let's, I didn't open the file before, it's here. So let me just copy this part here. So this is the part where I import libraries, and I can import Amplify. This file, AWS exports, is automatically generated by the CLI. It will contain all my AWS configuration, like the ID of my Cognito user pool, the S3 bucket that I want to use, anything that if I create APIs with the GraphQL and AppSync, everything will be configured here automatically. I don't need to edit my code. And then I import from AWS React one of the high-level components that we have for React. It's called with Authenticator. This Amplify configure will use the configuration from the file that we keep updated. And then I can take this final line here and push it here. So normally with React, you export the application. I comment this, and I export the application with Authenticator. And now the application, without changing any line of code, will have will use Cognito for authentication. And then you can configure if you want to have an open authentication when everybody can subscribe, if you want to use email, phone numbers. This is all the configuration that you can usually do. So I saved the store here. Now I can use, for example, Amplify add API to generate GraphQL or REST APIs, and it will automatically configure AppSync or the API gateway and create Lambda function. And I can do Amplify add out to add authentication. So for example, you can use, let's use the default configuration, but here you can tailor the authentication if it's open, it's closed, or not. Then you do Amplify push, will push your local configuration to the cloud. And this will create now the authentication, so the Cognito user pool that you need to use. So if we go back here, we see that the application is in update, and we also are creating a new stack. This is using a feature of CloudFormation that is called nested stacks. So you can have a stack and then smaller stacks that are nested. It's a way to create a more modular CloudFormation template instead of putting everything together. And this one is creating the Cognito user pool. It usually takes a few minutes. And when it's ready, we will be able to log in my application. To give you an idea of what you can do, I played with this technology in a few weekends. Let me sign out, sorry. This is a game that I built. So yeah, as you can expect, by my age, I used to play with text games lots of years ago. And it's a way to play in the game. So this is the authentication that you get out of the box with Amplify. So I can log in here with my user and my super secret password. And this is all using, this is a text maze. I think we can zoom a little bit. And every step that I'm doing, I'm interacting with Aws Amplify using GraphQL. This is just to give you an idea of the speed. And then you can, and there is DynamoDB in the backend. And then there are objects that you can interact with. Like, for example, there is now a brown cask, and I can use a hammer to break the cask. And then inside the cask, there is some coins and a salad. And let's eat the salad because it's late in the afternoon. So this is an example of what you can do. And if you want to have a little bit of fun on this, and you're old like me and you like this kind of game, is maze.nilop.net. And you just need to create an account. No GDPR management on my side because I don't look at the accounts. So if we look here, this was to fill up the time, but of course, when you do the last demo, everything is a little bit slower. So let's see CloudFormation here. The creation is still in progress. Let's see in the events. It's still creating the user pool. It's still creating the user pool. Oh, creation complete. So I think we're getting there. It should end very quickly because the second task, the second stack should be depending on the first one. It's probably going to finish as soon as I drop out. But the idea was just to show you how now the application that we were using is now protected by Cognito. Let's close this. This is the React application. OK. We should be there. No, today it's going slower than expected. Let's see. OK, creation complete, and this is completed. So I already updated the source code. So what I can do another yarn start, because I terminated the previous one. Otherwise, I could. And now, when this is the development environment is starting, and now when the same application is protected, so when the development server starts, I should see the same login as before, and then you can register and use the app. OK, yeah. And this is now the same application as before, but it's protected, and then you can create an account, and we manage email validation, and optionally we can do phone number validation via SMS if you prefer. And I just needed to add those few lines of code here. So import Amplify. Every time I was doing those configuration with the CLI, the AWS export file was updated with the configuration of Cognito, anything that was created on AWS. And then I just added the authenticator here to protect my app. Include greetings means that I also get, similarly to what you see here in the game, the possibility to sign out with the name of the user. So some very high-level sign-out capabilities if you want. And that's it for the demo, and almost for the day. So I hope it was interesting, and I'm really looking forward to see what you're going to build with all the things that you saw today. I hope you have a few ideas more than when you arrived this morning. And I'm happy if you want to do any question on this specific session, happy to take questions. Thank you. Any question? Usually the first one is the... sorry.
What frameworks do you have plugins for?
Sorry?
What sort of web frameworks do you have plugins for? Like you demoed React, but you have something for like Rails or...
Yes, so React was one of the very first that we integrated with Amplify, but we now support lots of different frameworks from Vue.js to, how's the other one that everybody's using now? I'm a little bit tired, but there's 4 or 5 frameworks that we support for JavaScript. And then we are adding features for native development. So for example, one of the features that we add recently is all the, if you use GraphQL, we automatically generate all the starting code for iOS and Android to start using GraphQL in your application with all the types that you created. So it's much, much easier to start using GraphQL also for native applications. And Amplify is completely open source. So if you want to look at where the development is going, or if you want to open suggestion for new features, the development is completely in the open. And it's also designed to be not AWS specific. So all the features that we create with Amplify normally have a handler that currently has maybe an implementation on AWS or for the specific framework. But if you want to add your own customization, it's completely pluggable. Any other question? The last question of, okay.
Are we using the AWS mobile CLI?
So Amplify is in theory replacing the AWS mobile. So the AWS mobile CLI is still there. We will support it, but we are not going to add new features, while the active development is now on Amplify. High-level overview, they are similar, but Amplify CLI is much more powerful, and we're adding new features. I didn't enter into some interesting detail, but if you do Amplify add API, then you can really create a model or storage database API with GraphQL and API with REST, everything from the CLI with some editing on and then we generate all the configurations for you. And everything is automatically put into CloudFormation, so you don't need to do that as well. We do that for you. So it's interesting. Okay, I think it's time. It's been a long day. I hope you enjoyed. Give us your feedback, what we can improve, what you liked, what you didn't like, and have fun with this stuff. Thank you.